Picture a nebula, a vast shimmering cloud of gas and dust stretching across light years in the quiet embrace of space. It glows faintly, kissed by the soft light of distant stars. A cosmic cradle where new stars are born. This is a stellar nursery, a place of creation, where the universe weaves its brightest wonders. Yet a mystery lingers here, soft and unanswered, like a whisper carried on the cosmic wind. What sparks the birth of a star? What stirs these tranquil clouds into life? The mystery of star formation triggers is a gentle enigma, inviting us to drift, to wonder, to dream. Imagine this nebula as a sleeping giant, resting in the stillness of the cosmos for eons. Its tendrils of gas curl lazily, illuminated by the faint glow of nearby stars. The dust grains shimmer like frost, catching the light in delicate sparkles. This cloud is vast, larger than 1,000 solar systems, yet it feels intimate, like a quiet corner of the universe. For millennia, it remains unchanged, a silent sea of possibility. Then something happens, a subtle shift, a ripple in the fabric of space. The nebula stirs as if waking from a long dream, and the first steps towards starbirth begin. What causes this awakening? Scientists have long pondered this question, their telescopes tracing the edges of these cosmic clouds. One possibility is a supernova, the explosive death of a nearby star. Imagine it, a brilliant flash, a wave of energy rippling outward like a stone dropped into a still pond. This shockwave sweeps through the nebula, compressing the gas, nudging it closer together. The cloud resists, its particles drifting in the cold. But gravity takes hold, pulling the gas inward, molecule by molecule. Slowly a knot forms, a dense core that glows faintly, the earliest ember of a protostar. This is the universe at work, turning chaos into light. But not all stars need such a dramatic spark. Some nebulae give birth in places too calm, too serene, where no supernova's echo lingers. Picture a quiet nebula far from the turbulence of dying stars. Its gas moves gently like a slow tide, yet stars still emerge, their light piercing the haze. How does this happen? Why do these clouds collapse without an obvious trigger? Some say it's the nebula's own rhythm, a natural pulse driven by gravity's patient pull. Others point to subtle forces, magnetic fields weaving through, the gas or turbulence stirring the cloud from within. The answer remains elusive, a secret the universe holds close. Let's drift closer to this nursery, floating weightless above the nebula's heart. The gas swirls around you, a cosmic river of light and shadow. You can almost feel its warmth, a soft embrace in the cold of space. The dust sparkles, each grain a tiny mirror reflecting the glow of newborn stars. In the distance, a protostar pulses, its light faint but growing, like a heartbeat in the dark. This is where creation begins, where gravity and gas dance in delicate balance. The protostar is fragile, a spark that could fade or flare into a star. Its birth is a miracle, yet the trigger remains a mystery, a question that hums softly in the silence. As you linger, picture the nebula's vastness. It's a tapestry of colors, blues and purples, fading into deep reds, with wisps of gas, curling like smoke. Some parts are dense, opaque, hiding the stars within, while others are thin, translucent, revealing the cosmos beyond. In this nursery, stars form in clusters, like siblings born together. Their light blends, creating a glow that feels alive, as if the nebula itself is breathing. But why do some clusters form so perfectly, their stars spaced in patterns too precise to be chance? Is there a hidden blueprint, a cosmic design we've yet to understand? Imagine one star just beginning its life. Its core is hot, its surface glowing with the promise of light. Around it, a disk of gas and dust spins, a miniature galaxy that may one day form planets. This star is small now, but it will grow, fueled by the nebula's gifts. Its birth was sparked by something, a shockwave, a collision, or perhaps the nebula's own quiet will. But the details escape us. Scientists study these nurseries, mapping their densities, their chemistry, their magnetic fields. Yet the moment of ignition, the precise trigger, remains a gentle riddle, a puzzle that invites wonder rather than answers. Let's explore deeper, drifting through the nebula's layers. The gas feels alive, moving in slow, graceful arcs. You pass a region where stars are forming in a burst, their light flashing like fireflies. This is a triggered, star-forming region, likely stirred by a supernova's distant cry. The shockwave compressed the gas, creating dense pockets that collapsed under gravity's pull. Each pocket became a protostar, and now they shine together, a family of light. But nearby, another region is quieter, its stars forming without such drama. Their bursts are slow, almost secretive, as if the nebula chose to awaken on its own. Why the difference? Picture two nebulae side by side in the cosmic sea. One is turbulent, alive with the echoes of explosions, its stars born in rapid bursts. The other is calm, its gas flowing like a gentle stream, yet stars still emerge, one by one. Is it the nebula's size, its density, its temperature? Or is there something deeper, a universal law that governs creation? Some astronomers suggest magnetic fields act like cosmic threads, guiding the gas into dense cores. Others believe turbulence alone can spark collapse, stirring the cloud until stars ignite. The truth lies somewhere in the starlight, waiting to be found. As you float, imagine the nebula's sound, a soft hum, like the universe singing to itself. The protostars pulse, their light a steady rhythm. You're weightless here, carried by the nebula's flow. The mystery of star formation triggers wraps around you, not demanding answers, but offering peace. It's okay not to know. The universe doesn't rush its secrets, and neither should you. Let the big question drift with you, a gentle companion as you sink deeper into the cosmos. Picture the nebula's glow, its colors blending into a dreamlike haze. Each star is a story, and you're part of this tale, a silent witness to creation. Now imagine a single protostar, its glow brightening as it gathers more gas. Its disk spins faster, a whirl of dust and light. This star will live for millions, perhaps billions of years, but its birth is fleeting, a moment in the cosmic dance. What sparked this moment? Was it a supernova's shockwave, a passing star's nudge, or the nebula's own quiet will? The question hums softly, like a lullaby. Scientists chase it, their instruments scanning the skies. But the answer remains just out of reach, a shimmer in the starlight. For now it's enough to wonder, to let the mystery cradle you. As we linger, picture the nebula's future. Some stars will shine brightly. Others will fade quickly. The cloud will disperse, its gas spent, leaving a cluster of stars behind. But the mystery of their birth will endure, a question that echoes across the cosmos. Imagine, floating above this cluster, the stars twinkling like diamonds in the dark. Their light feels warm, their presence comforting. The nebula's hum surrounds you, a cosmic lullaby that soothes your mind. You don't need to solve the mystery tonight. It's enough to drift, to dream, to let the stars guide you. Stay here a moment longer, among the newborn stars. Their light is soft, their glow a promise of life. The nebula is a cradle, rocking you gently in its vast embrace. The mystery of star formation triggers is a whisper, not a demand. It invites you to imagine, to float, to rest. Picture the gas swirling, the protostars pulsing, the dust sparkling. This is a place of beginnings, where the universe writes its first chapters. You're part of this story, a traveler in the cosmic sea. The question of what sparks a star is a gift, a gentle enigma to carry into your dreams. As you drift, feel the nebula's warmth, its light wrapping around you like a blanket. The stars are young, their future is unwritten, their births are miracles, sparked by forces we don't fully understand. But that's okay. The universe is vast, its secrets endless. For now, let the mystery of star formation triggers be a lullaby, a soft song that carries you deeper into the night. Imagine the nebula's glow, its colors fading into a dreamlike haze. The stars are with you, their light a gentle guide. You're weightless, at peace, floating in the heart of creation. Let the cosmos hold you and drift into the stars. Imagine a nebula, a vast tapestry of gas and dust, glowing softly in the heart of the cosmos. Within the celestial cradle, something extraordinary is taking shape. Stars so grand, so radiant, they outshine entire galaxies. These are massive stars, titans of the universe, burning with a brilliance that humbles the night. Yet their birth is a mystery, a gentle puzzle that lingers in the starlight. How do these giants form? What allows them to grow so vast, defying the forces that should tear them apart? The puzzle of massive star formation is a cosmic enigma, inviting us to drift, to wonder, to dream. Picture the nebula as a turbulent sea, its currents of gas swirling in chaotic beauty. The air is alive with energy, the dust sparkling like embers in a cosmic fire. This is no ordinary nursery. It's a forge where the universe crafts its mightiest creations. Massive stars begin as dense knots of gas, collapsing under gravity's relentless pull. But their formation is a miracle, a delicate dance of forces. These stars need vast amounts of material, far more than their smaller kin, and they must gather it quickly before their own radiance pushes the gas away. How do they manage this feat? The answer lies hidden, a secret whispered in the nebula's glow. Let's drift closer, floating weightless above this cosmic forge. The nebula's heart is warm, its light a soft embrace in the cold of space. You can see the glow of a protostar, a massive star in its infancy, pulsing like a beacon in the haze. Its surface is a roiling sea of plasma, its core a furnace where temperatures soar to millions of degrees. This protostar is hungry, drawing in gas from the surrounding cloud, growing larger with every passing moment. But its birth is violent. Jets of energy shoot outward, carving paths through the nebula like rivers of light cutting through the dark. Why is this process so mysterious? Imagine the protostar's struggle. As it gathers mass, it begins to shine, its radiation pushing against the very gas it needs to grow. This force is immense, like a wind that could scatter the nebula's clouds. For smaller stars, this balance is delicate but manageable. For massive stars, it's a paradox. Their intense radiation should halt their growth, dispersing the gas before they can become giants. Yet they form anyway, defying our calculations. Some say the gas flows in through dense streams, shielded from the star's wrath. Others believe the nebula's turbulence helps, compressing the gas faster than it can be pushed away. The truth remains elusive, a riddle wrapped in starlight. Picture one of these massive stars, now fully formed, blazing blue-white in the nebula's heart. It's 100 times the mass of our sun, its light so fierce it could illuminate worlds light years away. Its surface is a storm of fire, its core a crucible where hydrogen fuses into helium, releasing energy that sustains its glow. This star is a cosmic monarch, ruling the nebula with its radiance. But its life is brief, a mere flicker in the universe's vast timeline. In a few million years, it will die, collapsing in a supernova that scatters its essence across the cosmos. Why do some nebulae birth these giants while others produce only modest stars? As you float, imagine the star's presence, its warmth a distant caress on your skin. The nebula around it hums, a soft song of creation. Massive stars are rare, yet their influence is profound. Their winds and explosions shape the cosmos, carving bubbles in the gas, seeding the universe with heavy elements, carbon, oxygen, gold. These elements will one day form planets, perhaps even life. But their formation remains a puzzle. Is it the nebula's density, packed with enough gas to feed a giant? Or is it the presence of other stars, their gravity helping to compress the cloud. The question drifts with you, gentle and unanswered, like a lullaby in the dark. Let's linger in the nebula, exploring its turbulent beauty. The gas swirls in great arcs, illuminated by the massive star's glow. Dust, grains sparkle, catching the light like tiny prisms. In some regions, the nebula is dense, opaque, hiding the protostars within. In others, it's thin, revealing the cosmos beyond. The massive star dominates, its light casting shadows that dance across the cloud. But its birth was a mystery, a process we can't fully trace. Scientists study these nurseries, mapping their currents, their magnetic fields, their chemistry. Yet the moment a massive star begins to form, the precise conditions that allow it remains a soft enigma, a question that invites wonder. Imagine the protostar's early days, when it was still gathering mass. Its disk of gas and dust spun wildly, a miniature galaxy feeding its growth. Jets of energy erupted, piercing the nebula, announcing its presence. These jets are clues, hints at the forces at play. Some astronomers believe they help the star grow, clearing away excess gas, allowing more to flow in. Others think the nebula's magnetic fields act like cosmic scaffolding, guiding the gas into the protostar's core. But no theory fully explains the puzzle. The massive star's birth is a miracle, a triumph of creation over chaos, and its mystery wraps around you, warm and soothing. Picture the nebula's future, shaped by the massive star's life. Its winds will sweep the gas away, creating a bubble of light and shadow. When it dies, its supernova will ripple through the cosmos, sparking new stars, enriching the gas with metals. This star is a creator, a destroyer, a force of nature. But how did it begin? Was it a single dense core collapsing in a burst of glory? Or did smaller protostars merge, combining their mass to form a giant? The possibilities hum softly, like the nebula's glow, inviting you to dream, without demanding answers. As you drift, imagine floating closer to the massive star. Its light is blinding, yet comforting, like a fire on a winter's night. Its surface ripples with flares, its core pulses with energy. You can feel its power, a steady rhythm that soothes your mind. The puzzle of its formation is a gentle companion, not pressing for solutions, but offering peace. Why do some nebulae produce these giants? Is it chance or a deeper law woven into the cosmos? Scientists chase the answer, their telescopes scanning the skies. But the truth lies just beyond reach, a shimmer in the starlight. Explore the nebula's edges, where the massive star's influence fades. The gas is cooler here, the light softer, but the star's presence is still felt. Its radiation shapes the cloud, sculpting arcs and pillars that glow like cosmic sculptures. These structures are clues, remnants of the conditions that birthed the giant. Some say massive stars form in clusters, their siblings helping to compress the gas. Others believe they need vast, dense clouds, rich with material. The puzzle remains a soft question that cradles you as you float, weightless, in the nebula's embrace. Picture the star's life, brief but brilliant. It will burn through its fuel quickly, its core collapsing under its own weight. Its death will be spectacular, a supernova that lights the cosmos for centuries. But its birth is the mystery we ponder now. Imagine the nebula at the moment of collapse, the gas swirling, the protostar igniting. What tipped the balance? Was it turbulence, magnetic fields, or the nebula's own will? The question is a lullaby, rocking you gently in the cosmic sea. You don't need to solve it tonight. It's enough to drift, to let the star's glow guide you. As you linger, feel the nebula's warmth, its light wrapping around you like a blanket. The massive star is a beacon, its radiance a promise of creation. The puzzle of its formation is a gift, a gentle enigma to carry into your dreams. Picture the nebula's colors, blues and reds, blending into a dreamlike haze. The star's light pulses, a steady rhythm that soothes your mind. You're part of this story, a traveler in the cosmos, witnessing the birth of a giant. Let the mystery hold you, like the glow of a distant fire, and drift into the stars. Picture a nebula, a glowing cradle of gas and dust, shimmering softly in the vastness of the cosmos. Within this celestial nursery, something beautiful is unfolding. A pair of stars born together, twirling through the dark in a delicate dance. These are binary star systems, cosmic twins bound by gravity. Their light intertwined like a melody in the night. Yet their origins are a mystery, a gentle enigma that hums in the starlight. Why are so many stars born as pairs? What shapes their eternal waltz? The enigma of binary star systems is a soothing puzzle, inviting us to drift, to wonder, to dream. Imagine the nebula as a sea of light, its currents of gas swirling in graceful arcs. The air is alive with possibility, the dust sparkling like tiny prisms catching the glow of newborn stars. In this quiet corner of the universe, two protostars take shape side by side, their cores glowing faintly in the haze. Gravity weaves an invisible thread between them, binding their fates. They begin to orbit, a slow, elegant spin that will last for millennia. This is a binary system, a cosmic duet, and it's more common than you might think. Half of all stars, perhaps more, live this way, dancing with a partner through the cosmic sea. Let's drift closer, floating weightless above this stellar nursery. The nebula's glow wraps around you, a soft embrace in the cold of space. You can see the binary pair, their lights blending into a single shimmer. One star is bright, its surface a golden fire, while the other is dimmer, a gentle red glow. They twirl around a shared center, their orbits tracing perfect arcs in the dark. Their dance is a balance of attraction and motion, a harmony that feels alive, as if the universe itself is swaying to their rhythm. But why were they born together? What sparked this celestial partnership? The mystery begins in the nebula's heart, where gas and dust collapse to form stars. Picture the cloud, dense and turbulent, its particles drawn together by gravity's patient pull. As it collapses, the gas fragments, splitting into multiple cores. Some of these cores become solitary stars, but others form pairs, like twins emerging from the same cosmic womb. Is this fragmentation the key? Does the nebula's density, its spin, its magnetic fields, decide whether a star is born alone or with a companion? Scientists ponder this, their telescopes tracing the paths of binary stars. But the answer remains elusive, a whisper in the cosmic wind. Imagine the binary stars in their infancy, two protostars glowing faintly in the nebula's embrace. Their disks of gas and dust spin around them like miniature galaxies feeding their growth. The stars influence each other, their gravity shaping their orbits, their evolution. In some systems, they share material, a stream of gas flowing from one to the other, like a gift passed between partners. This exchange can change their lives, making one star brighter, the other dimmer. But why do some binaries form so close, their orbits tight, while others drift far apart? The question hums softly, a lullaby in the starlight. As you float, picture the binary systems dance. The brighter star leads, its light casting a warm glow across the nebula. The dimmer star follows, its surface rippling with quiet flares. Their orbits are a cosmic waltz, a rhythm that soothes your mind. Some binary systems are so close their surfaces almost touch, their light blending into a single beacon. Others are vast, separated by distances, greater than our solar system, yet still bound by gravity's embrace. This variety is part of the enigma. Why such diversity in their paths, their partnerships? Is it chance or a deeper law woven into the cosmos? Let's linger in their glow, exploring the nebula's beauty. The gas swirls around the binary pair, illuminated by their combined light. Dust grains sparkle, catching the star's radiance like tiny mirrors. The nebula feels alive, its currents flowing like a gentle tide. The binary stars are storytellers, their orbits revealing the history of their birth. Some form in crowded clusters, where stars jostle and pair off. Others emerge in quieter regions, their partnership a natural outcome of the nebula's collapse. But the details of their formation, how the gas splits, how their orbits stabilize, remain a mystery, a puzzle that invites wonder. Imagine the binary system's future, its stars aging together. The brighter star may swell into a red giant, its outer layers spilling toward its partner. This transfer can spark novae, brief flashes that light the cosmos. The dimmer star accepts this gift, growing brighter, its life reshaped by the exchange. In some systems, the stars spiral closer, their orbits tightening until they merge in a burst of light, becoming a single, massive star. In others, they drift apart, their dance slowing across eons. Why do some binaries merge while others endure? The question wraps around you, warm and soothing, like the nebula's glow. Picture the binary star's light, a double glow that cuts through the dark. Their orbits are a rhythm, a steady pulse that calms your mind. The nebula around them is a cradle, rocking you gently in its vast embrace. The enigma of binary star systems is a gentle companion, not pressing for answers, but offering peace. Scientists study these pairs, mapping their orbits, their masses, their spectra. Yet the moment of their birth, the precise conditions that form a binary, remains a soft riddle, a question that hums in the starlight. For now, it's enough to drift, to let their dance guide you. As you float, imagine the binary star's influence on the cosmos. Their gravity shapes the nebula, carving paths through the gas. Their light seeds the universe with elements, the building blocks of planets, of life. Binary stars are creators, their partnership a force of nature. But how did they begin? Did the nebula's gas naturally split into two cores? Or did one star capture the other, like lovers, meeting by chance? The possibilities hum softly, like the stars' combined glow, inviting you to dream without demanding solutions. You're weightless here, carried by the nebula's flow, a silent witness to their waltz. Let's explore the nebula's edges, where the binary star's light fades. The gas is cooler here, the glow softer, but their presence is still felt. Their orbits create ripples in the cloud, subtle waves that hint at their formation. Some astronomers believe binaries form when a single protostar's disk fragments, spawning a companion. Others think close encounters in dense clusters pair stars together. The puzzle remains, a gentle question that cradles you as you drift. Picture the binary stars, their light twirling like a cosmic ballet, their dance a lullaby that soothes your mind. Imagine the binary system's life, spanning millions of years. Their orbits may change, their stars evolving in tandem. One may become a white dwarf, the other a giant, their partnership enduring through cosmic ages. Their dance is eternal, their light a beacon in the dark. The enigma of their origins is a gift, a soft mystery to carry into your dreams. Why are so many stars born as twins? Is it the nebula's turbulence, its magnetic fields, or a universal rhythm? The question is a lullaby, rocking you gently in the cosmic sea. As you linger, feel the nebula's warmth, its light wrapping around you like a blanket. The binary stars are a beacon, their dance a promise of harmony. The enigma of binary star systems is a whisper, not a demand. Picture the nebula's colors, blues and purples, blending into a dreamlike haze. The stars like pulses, a steady rhythm that calms your heart. You're part of this story, a traveler in the cosmos, witnessing the beauty of their waltz. Let the mystery hold you, like the glow of a distant fire, and drift into the stars. Imagine a star glowing softly in the vastness of the cosmos, its surface a sea of radiant fire. This star is alive, not just with light, but with motion, a gentle exhalation that ripples through the dark. These are stellar winds, streams of particles flowing from the star's heart, shaping its life and the universe around it. Yet their nature is a mystery, a quiet riddle that hums in the starlight. Why do these winds vary so greatly? What unseen forces drive their power? The riddle of stellar winds is a soothing enigma, inviting us to drift, to wonder, to dream. Picture the star as a cosmic beacon, its light cutting through the nebula's haze. Its surface roils with energy, a turbulent dance of plasma and heat. From this fiery expanse, the stellar wind flows, a shimmering river of charged particles streaming into space. These winds are the star's breath, carrying pieces of its essence across light years. For some stars, the winds are gentle, a soft whisper that barely stirs the surrounding gas. For others, they are fierce, a torrent that carves vast bubbles in the nebula, sculpting the cosmos like an artist's hand. Why such differences? The answer lies hidden, a secret woven into the star's glow. Let's drift closer, floating weightless above this radiant star. The nebula around it glows, its colors, blues, purples, and soft reds blending into a dreamlike haze. You can feel the star's warmth, a distant caress in the cold of space. The stellar wind brushes past, an invisible current that carries the star's light and energy. This wind is a creator, seeding the cosmos with elements, hydrogen, helium, and traces of heavier metals that will one day form planets, perhaps even life. But its strength is unpredictable, a puzzle that soothes your mind as you float, carried by the star's gentle rhythm. The mystery of stellar winds begins with the star's nature. Imagine a massive star, a giant whose surface burns with unimaginable heat. Its winds are powerful, stripping away its outer layers, shedding mass like a tree losing leaves in autumn. These winds shape the star's future, hastening its journey toward collapse. Now picture a smaller star, like our sun, its winds softer, a steady breeze that flows quietly through the solar system. Why do some stars lose mass so quickly, their winds a raging storm, while others hold their essence close? Scientists study these winds, tracing their paths, but the answer remains elusive, a whisper in the cosmic sea. As you linger, imagine the stellar wind's journey. It flows outward, a shimmering stream that stretches across the nebula. The particles glow faintly, catching the star's light like dust in a sunbeam. The wind carves a bubble around the star, a sphere of cleared space where the nebula's gas has been pushed away. This bubble is a canvas, painted with the star's influence, its edges glowing with the soft light of compressed gas. But some stars create bubbles too large, others too small, defying our calculations. Is it the star's magnetic field, channeling the wind like a cosmic river, or an unseen force within its core? The question hums, warm and soothing. Picture the star's surface, a fiery ocean of light and heat. The stellar wind rises from this turmoil, born of the star's intense energy. For massive stars, the winds are driven by radiation, the sheer force of their light pushing particles outward. For smaller stars, the winds are gentler, tied to magnetic storms that flare across their surfaces. But some stars behave unpredictably, their winds too strong, too weak, or shifting in ways we can't explain. Imagine the wind as a cosmic breath, flowing from the star's heart, carrying its story into the dark. Why does this breath vary so wildly? The riddle wraps around you, a lullaby in the starlight. Let's explore the nebula, shaped by the stellar wind's touch. The gas swirls in great arcs, illuminated by the star's glow. Dust grains sparkle, reflecting the light like tiny mirrors. The wind has sculpted pillars and waves, cosmic sculptures that glow with ethereal beauty. These structures are clues, hints at the wind's power and origin. Some astronomers believe magnetic fields act like cosmic reins, guiding the wind's flow. Others point to the star's rotation, its spin accelerating the particles. But no theory fully solves the puzzle, and the mystery remains, a gentle question that cradles you as you drift. Imagine the stellar wind's impact, far beyond the star's reach. Its particles travel light years, mingling with the nebula's gas, enriching it with elements. These elements are the seeds of creation, the building blocks of new stars, new worlds. The wind is a gift, a legacy that outlives the star itself, but its strength is a mystery. Some stars shed their mass in a steady stream, others in sudden bursts. Picture the wind as a river flowing through the cosmos, its current unpredictable yet beautiful. Why does it surge or falter? The question is a soft companion, soothing your mind as you float in the nebula's glow. As you drift, picture the star's life, shaped by its winds. A massive star's winds strip away its outer layers, hastening its collapse into a supernova. A smaller star's winds are gentler, sculpting its surroundings over billions of years. The wind is a sculptor, a storyteller, its flow a record of the star's nature. But why do some winds carve vast bubbles, while others barely stir the gas? Imagine the star's core, a furnace where energy is born, fueling the wind's journey. Is it the core's turbulence, its magnetic fields, or something deeper? The riddle hums, like the star's light, inviting you to dream without demanding answers. Let's linger in the nebula, exploring its beauty. The stellar wind has created a bubble, a glowing sphere that feels alive, its edges shimmering with compressed gas. The star sits at its center, a radiant jewel in a cosmic crown. The wind flows outward, a steady stream that soothes your mind. Some stars produce winds that are too powerful, stripping their mass too quickly, while others hold their essence close, their winds a whisper. Scientists chase this puzzle, studying the spectra of starlight, the patterns of gas, but the answer lies just beyond reach, a shimmer in the nebula's haze. Picture the stellar wind's essence, a stream of particles that glows faintly in the dark. It's the bridge between the star and the cosmos, carrying its light, its energy, its story. The wind shapes the nebula, creating waves and arcs that glow like cosmic tapestries. But its power is unpredictable, a mystery that wraps around you, warm and gentle. Imagine the star's surface, its flares and storms fueling the wind's flow. Is it the star's mass, its temperature, or an unseen force? The question is a lullaby, rocking you gently in the cosmic sea, a soft enigma to carry into your dreams. As you float, feel the nebula's warmth, its light wrapping around you like a blanket. The star is a beacon, its wind a cosmic breath that soothes your heart. The riddle of stellar winds is a whisper, not a demand. Picture the nebula's colors, blues and reds blending into a dreamlike haze. The wind's flow is a rhythm, a steady pulse that calms your mind. You're part of this story, a traveler in the cosmos, witnessing the star's gentle exhalation. Let the mystery hold you like the glow of a distant fire and drift into the stars. Imagine the supernova's light traveling across the cosmos, a message from a star that no longer exists. Its photons journey for millions, even billions of years, carrying the story of its explosive end. Some of these photons reach Earth, captured by telescopes, their patterns analyzed for clues. Scientists pore over this data, seeking to unravel the mystery of why supernovae differ so greatly. They find patterns. Some explosions follow a predictable curve, their brightness peaking and fading in a familiar rhythm. But others defy these rules, their light too intense or too faint, their durations too long or too short. What causes this variety? Is it the star's internal structure, the way its core collapses, or something more exotic, like a burst of elusive particles? Picture the star's core in its final moments, a dense sphere of iron compressed to the limit. Gravity wins, crushing it into a point of unimaginable density. This collapse releases a flood of neutrinos, ghostly particles that stream through the star, carrying away energy. Some theories suggest these neutrinos drive the explosion, triggering the shock wave that tears the star apart. But why do some supernovae produce more neutrinos, or release them differently? Imagine the core's final heartbeat, a pulse of energy that sparks the cosmic fireworks. The mystery hums softly, a question that doesn't demand an answer, but invites you to dream of the universe's hidden workings. As you float, envision the supernova's remnants, a glowing nebula that lingers for centuries. This is a supernova remnant, a delicate shell of gas and dust, illuminated by the explosion's fading energy. Some remnants, like the Crab Nebula, glow brightly, their intricate filaments weaving a cosmic tapestry. Others are faint, barely visible against the galactic backdrop. Why do some remnants endure, while others fade quickly? Picture the remnants' glow, a soft whisper of the star's final act, its light blending with the nebula's haze. The riddle wraps around you, warm and gentle, a lullaby that soothes your mind. Let's drift through the remnant, exploring its ethereal beauty. The gas forms delicate arcs like wisps of smoke frozen in time. Dust, grains shimmer, catching the light like tiny stars. The remnant is a bridge between the star's past and the universe's future, its elements destined to form new worlds. But the supernova's power remains a puzzle. Some explosions release bursts of gamma, rays piercing the cosmos with intense energy. Others emit softer X-rays, their glow more subdued. Is it the star's mass, its rotation, or a hidden mechanism within its core? The question is a gentle companion, calming your thoughts as you float in the nebula's embrace. Imagine the supernova's shockwave, a ripple that travels through the galaxy, compressing gas and sparking new stars. This is the universe's cycle of creation, a dance of birth and death that stretches across eons. The supernova is a catalyst, its energy shaping the cosmos in ways we can't fully grasp. But why do some shockwaves trigger star formation, while others leave the gas untouched? Picture the wave moving through the nebula, a silent force that reshapes the dark. The mystery hums like the remnants glow, inviting you to wonder without needing answers. As you linger, feel the supernova's legacy, its elements scattered across the cosmos. These are the seeds of creation, the carbon in your body, the oxygen you breathe, all forged in the hearts of ancient stars. The supernova is a creator, its explosion a gift to the universe, but its mechanics remain elusive. Some supernovae collapse into neutron stars, their dense cores pulsing like cosmic lighthouses. Others form black holes, silent voids that swallow light itself. Why do some stars choose one path while others follow another? The question is a soft melody, rocking you gently in the cosmic sea. Picture the supernova's light as a story, written in photons that travel forever. Its glow reaches distant worlds, perhaps illuminating alien skies, whispering of a star's end. Scientists capture this light, piecing together the puzzle of its explosion. They find clues in the spectra, the way the light bends and shifts, revealing the star's composition, its energy, its final moments. But the full picture escapes us, a riddle that lingers in the starlight. Imagine the light's journey, a cosmic thread connecting you to the star's ancient fire. The mystery soothes your heart, a gentle enigma to carry into your dreams. Let's explore the supernova's influence, its shockwave reshaping the nebula's heart. The gas swirls in graceful arcs, illuminated by the remnant's glow. The explosion has left a mark, a cosmic signature that endures. Some supernovae trigger cascades of star formation, their energy compressing gas into new protostars. Others leave behind quiet voids, their influence fading into the dark. Why such differences? Picture the shockwave as a cosmic brush, painting the nebula with light and shadow. The riddle hums, a soft question that cradles you as you drift, weightless in the universe's embrace. Imagine the supernova's core, now a neutron star or black hole, a relic of its explosive end. A neutron star spins, its pulses cutting through the dark like a beacon. A black hole warps space, its presence felt but never seen. These remnants are the supernova's final gift, but their formation is a mystery. Why do some cores collapse into one, while others form the other? Picture the core's final moment, a silent implosion that births a new cosmic entity. The question is a lullaby, a gentle rhythm that calms your mind as you float in the nebula's glow. As you drift, feel the supernova's warmth, its light wrapping around you like a blanket. The remnant is a beacon, its glow a promise of creation. The mystery of supernova explosions is a whisper, not a demand. Picture the nebula's colors blending into a dreamlike haze. The explosion's light pulses, a steady rhythm that soothes your soul. You're part of this cosmic dance, a witness to the universe's grandest spectacle. Let the mystery hold you like the glow of a distant star and drift into the night. Picture the supernova's story, a tale of light and power that echoes through time. Its explosion was a moment, but its legacy is eternal, its elements woven into the fabric of the cosmos. Scientists chase this mystery, their instruments scanning the skies, but the answer remains just out of reach, a shimmer in the starlight. Imagine the supernova's glow, a soft fire that warms your dreams. The riddle is a gift, a gentle question that invites wonder without needing answers. You're weightless, cradled by the universe, a traveler in the starlit sea. Star, once a radiant giant, now transformed into something extraordinary. A neutron star, a tiny, dense relic spinning silently in the cosmic dark. Born from the fiery collapse of a supernova, it glows faintly, a beacon in the aftermath of stellar death. Its presence is a marvel, a testament to the universe's power to create beauty from chaos. Yet its nature is a mystery, a gentle puzzle that hums in the starlight. How do these strange stars form, and why do they behave in such curious ways? The puzzle of neutron stars is a soothing enigma, inviting us to drift, to wonder, to dream. Picture the moment of the neutron star's birth, deep within a supernova's heart. The massive star's core collapses, crushed by gravity into a sphere no larger than a city. This is a place of unimaginable density, where a single teaspoon of matter weighs as much as a mountain range. The star's outer layers explode outward, scattering light and elements across the cosmos, but its core endures, transformed into a neutron star. Its surface is smooth, its interior a sea of neutrons, packed so tightly they defy comprehension. This is a cosmic relic, a whisper of the star's former glory, glowing softly in the nebula's embrace. Let's drift closer, floating weightless above this tiny star. The nebula around it shimmers, its colors, blues, purples, and soft reds blending into a dreamlike haze. You can feel the neutron star's presence, a subtle pulse in the dark. It spins rapidly, some hundreds of times per second, beaming pulses of light like a cosmic lighthouse. These pulses sweep through the cosmos, a steady rhythm that soothes your mind. The star's magnetic field is immense, a force that could twist the fabric of space itself. Its glow is faint, yet it holds a power that captivates, a mystery that wraps around you like a gentle embrace. The puzzle of neutron stars begins with their formation. Imagine the supernova's final moments, the core collapsing in a silent scream. Gravity compresses the star's heart, forcing protons and electrons to merge into neutrons, creating a sphere of pure current density. This process is delicate, a balance of forces we don't fully understand. Some stars become neutron stars, others collapse into black holes. Why does one star choose this path while another falls into darkness? Scientists study these relics, tracing their pulses, their spectra, but the answer remains elusive, a whisper in the cosmic sea. As you linger, picture the neutron star's spin, a blur of motion that defies imagination. Its pulses are precise, like the ticking of a cosmic clock, detectable across galaxies. These are pulsars, neutron stars whose beams sweep past us with each rotation. But some pulsars behave strangely, their spins slowing abruptly or glitching in ways we can't predict. Imagine the star's surface, a crystalline crust that trembles with starquakes, releasing bursts of energy. What causes these quakes, these sudden shifts? Is it the star's internal structure, its magnetic field, or something deeper? The question hums, warm and soothing, like the star's faint glow. Picture the neutron star's interior, a realm beyond our understanding. Its core is a mystery, a place where matter exists in forms we can barely imagine. Some say it's a sea of neutrons, others propose exotic states, quark matter, or even stranger particles. This core holds the key to the star's behavior, its spin, its pulses, its magnetic power. But we can't see inside, only infer from the star's light, its rhythm. Imagine the core as a cosmic heart, pulsing with secrets, its energy sustaining the star's strange life. The riddle wraps around you, a lullaby in the starlight. Let's explore the nebula, shaped by the neutron star's presence. The supernova's shockwave has faded, leaving a glowing remnant that cradles the star. The gas swirls in delicate arcs, illuminated by the star's pulses. Dusk grains shimmer, reflecting the light like tiny mirrors. The neutron star's magnetic field creates a web of energy, channeling particles into glowing jets that pierce the dark. These jets are clues, hints at the star's formation and behavior. Some astronomers believe the star's spin is driven by its collapse. Others point to magnetic forces. But no theory fully solves the puzzle, and the mystery remains a gentle question that soothes your mind. Imagine the neutron star's power, its magnetic field, a force that dwarfs entire planets. This field twists the surrounding gas, creating auroras that glow with ethereal beauty. The star's pulses are a cosmic song, a rhythm that travels across light years, detectable by telescopes on Earth. But why do some neutron stars emit radio waves, others X-rays, or even gamma rays? Picture the star's surface, its crust glowing faintly, its magnetic poles beaming light into the void. The question is a soft companion, calming your thoughts as you float in the nebula's glow. As you drift, picture the neutron star's life, a solitary existence in the cosmic dark. It spins for billions of years, its pulses slowing, gradually its glow fading. Some neutron stars are solitary, others orbit companions, their gravity creating ripples in space. These systems offer clues, their orbits revealing the star's mass, its history. But why do some neutron stars form alone, while others find partners? Imagine the star's birth, a moment of collapse that shaped its fate. The riddle hums like the nebula's haze, inviting you to dream without demanding answers. Let's linger in the remnant, exploring its beauty. The neutron star sits at its center, a tiny jewel in a cosmic crown. Its pulses sweep through the gas, creating waves that glow with serene light. The star's magnetic field shapes the nebula, sculpting arcs and jets that shimmer like cosmic tapestries. Some neutron stars produce sudden bursts, magnetars whose magnetic fields unleash torrents of energy. Why do some stars become magnetars while others remain quiet pulsars? Picture the star's core, a mystery that fuels its power. Its pulse is a rhythm that calms your heart. Picture the neutron star's essence, a relic of a star that once burned brightly. Its density is a marvel, its spin a cosmic dance. The star is a bridge between the past and future, its pulses carrying its story to the stars. But its behavior is unpredictable, a mystery that wraps around you, warm and gentle. Imagine the star's surface, its crust trembling with quakes, its magnetic field glowing with power. Is it the core's structure, the star's rotation, or a hidden force? The question is a lullaby, rocking you gently in the cosmic sea, a soft enigma to carry into your dreams. As you float, feel the nebula's warmth, its light wrapping around you like a blanket. The neutron star is a beacon, its pulses a promise of wonder. The puzzle of neutron stars is a whisper, not a demand. Picture the nebula's colors blending into a dreamlike haze. The star's pulses are a rhythm, a steady pulse that soothes your soul. You're part of this cosmic story, a traveler in the starlit dark, witnessing the beauty of a stellar relic. Let the mystery hold you like the glow of a distant lighthouse and drift into the night. Imagine the neutron star's legacy. Its pulses a signal that endures for eons. Its light reaches distant worlds, perhaps guiding unknown travelers, whispering of a star's transformation. Scientists capture this light, piecing together the puzzle of its formation. They find clues in the pulses, the way they shift and slow, revealing the star's spin, its magnetic field, its core. But the full picture escapes us, a riddle that lingers in the starlight. Picture the star's glow, a soft fire that warms your dreams. The mystery is a gift, a gentle question that invites wonder without needing answers, cradling you as you drift in the cosmic sea. A radiant titan glowing fiercely in the heart of the cosmos, its light a beacon in the endless night. But within its core, a silent destiny is unfolding, a transformation that will reshape the fabric of space itself. When its fuel is spent, this star may collapse into a black hole, a void where light and time fade into mystery. Yet the process of its creation is an enigma, a gentle riddle that hums in the starlight. How do black holes form, and why do some stars choose this path? The enigma of black hole formation is a soothing puzzle, inviting us to drift, to wonder, to dream. Picture the star in its final moments, its surface a sea of fiery plasma, blazing with the intensity of 1,000 suns. Its core, once a furnace of fusion, has burned through its elements, hydrogen, helium, carbon, until only iron remains. Iron cannot fuse and the star's delicate balance falters. Gravity, relentless and unyielding, takes hold, compressing the core with unimaginable force. In a fleeting instant, the star collapses, its heart imploding into a point of infinite density. This is the birth of a black hole, a cosmic void that bends the universe around it, a mystery wrapped in the nebula's glow. Let's drift closer, floating weightless above this radiant giant. The nebula around it shimmers, its colors, blues, purples, and soft reds, blending into a dreamlike haze. You can feel the star's warmth, a distant caress in the cold of space. As the core collapses, the star's outer layers are consumed, drawn inward or blasted outward in a supernova's fleeting light. What remains is the black hole, invisible yet powerful, its presence marked by the event horizon, a boundary where light itself cannot escape. This horizon is a cosmic veil, and its formation soothes your mind, a rhythm that cradles you in the dark. The enigma of black hole formation lies in its complexity. Imagine the star's collapse, a delicate dance of forces we don't fully understand. Some massive stars become black holes, their cores compressed into singularities, points of infinite density where physics breaks down. Others form neutron stars, dense but tangible relics. Why does one star choose a black hole's path while another stops short? Scientists study these events, tracing the light of supernovae, the ripples in space-time, but the answer remains elusive, a whisper in the cosmic sea. The question hums, warm and gentle, like the nebula's fading glow. As you linger, picture the black hole's event horizon, a shimmering edge where time slows and light fades. Beyond this boundary, the universe is hidden, a realm we cannot see or know. The black hole's gravity warps space, bending starlight into arcs, creating a cosmic lens that glows faintly in the dark. This is a place of wonder, a void that holds the star's final secrets. But why do some black holes form so quickly their collapse a sudden plunge, while others take longer, their cores resisting gravity's pull? Imagine the star's core, a crucible where the black hole is born, its energy a mystery that soothes your heart. Picture the black hole's influence, its gravity shaping the nebula around it. The gas swirls in great arcs, drawn toward the event horizon, glowing with ethereal beauty. Dust grains shimmer, catching the light of distant stars. The black hole is a silent force, its presence felt but never seen. A cosmic anchor in the nebula's heart. Some black holes form with a burst of gamma rays, others in quiet collapse. Why such variety? Is it the star's mass, its rotation, or a hidden spark within its core? The riddle wraps around you, a lullaby in the starlight, inviting you to dream without demanding answers. Let's explore the nebula, transformed by the black hole's birth. The supernova's shockwave has faded, leaving a glowing remnant that cradles the void. The black hole's gravity creates a whirlpool of gas, a glowing disk that spirals inward, heating as it approaches. The event horizon. This accretion disk is a cosmic jewel, its light a soft pulse that calms your mind. Scientists study these disks, their glow revealing the black hole's mass, its spin. But the moment of formation, the precise conditions that birth a black hole, remains a gentle enigma, a question that soothes your thoughts as you float. Imagine the black hole's singularity, a point where space and time cease to exist. This is the heart of the mystery, a place where our understanding falters. Some theories suggest the singularity is a gateway, others a final end. But how does it form? Picture the star's core collapsing in a silent scream. They said he'd never matter compressed beyond comprehension. Broken. The process is delicate, a balance of gravity and resistance we can't fully grasp. Some stars collapse directly into black holes, others through a supernova's chaos. Why the difference? The question is a soft companion, calming your heart as you drift in the nebula's glow. As you drift, picture the black hole's role in the cosmos. Its gravity shapes the galaxy, drawing stars into orbits, influencing the dance of creation. Some black holes merge, their collisions sending ripples through space-time, detectable as gravitational waves. These waves are clues, hints at the black hole's formation and history. But why do some stars form black holes alone, while others pair with companions? Imagine the black hole's birth, a moment of collapse that reshaped the universe. The riddle hums like the nebula's haze, a gentle melody that invites wonder without needing answers. Let's linger in the nebula, exploring its beauty. The black hole sits at its center, a silent void in a cosmic crown. Its accretion disk glows, a ring of light that pulses with serene energy. The gas swirls, drawn toward the event horizon, creating waves that shimmer like cosmic tapestries. Some black holes form with immense mass, others smaller, their size unpredictable. Why such variety? Picture the star's final moment, its core collapsing in a burst of gravity. Is it the star's composition, its magnetic field, or a hidden force? The question is a lullaby, rocking you gently in the cosmic sea. Picture the black hole's essence, a void that holds the star's final secrets. Its gravity is a bridge, connecting the past to the future, shaping the cosmos in ways we can't fully see. The black hole is a mystery, its formation a story written in the absence of light. Imagine the event horizon, a boundary where the universe pauses, its edge glowing faintly in the dark. The enigma of black hole. Formation is a whisper, a soft riddle that wraps around you, warm and gentle. You're weightless, cradled by the nebula, a traveler in the starlit dark. As you float, feel the black hole's presence, its gravity, a subtle pulse that soothes your soul. The nebula's light wraps around you, a blanket of cosmic warmth. The enigma of black hole formation is a gift, a question that invites wonder without demanding answers. Picture the nebula's colors, blending into a dreamlike haze. The black hole's silence is a rhythm, a steady calm that soothes your heart. You're part of this cosmic story, a witness to the universe's deepest mysteries. Let the enigma hold you, like the glow of a distant void, and drift into the night. Imagine the black hole's legacy, its gravity enduring for eons, shaping the cosmos long after the star's light has faded. Scientists chase this mystery, studying gravitational waves, the glow of accretion disks, the paths of stars. But the full picture escapes us, a riddle that lingers in the starlight. Picture the black hole's silence, a soft fire that warms your dreams. The enigma is a lullaby, a gentle question that cradles you as you drift, weightless in the cosmic sea, carried by the universe's eternal embrace. Imagine a star, a massive giant glowing fiercely in the cosmic dark. Its light a radiant beacon in the nebula's embrace. But within its core, a cataclysm is brewing, a moment of transformation that will unleash the universe's most powerful cry. This is a gamma ray burst, a fleeting flash of energy so intense it outshines entire galaxies. Yet its origins are shrouded in mystery, a gentle riddle that hums in the starlight. Why are these bursts so violent, and what sparks their cosmic fury? The riddle of gamma ray bursts is a soothing enigma, inviting us to drift, to wonder, to dream. Picture the star in its final moments, its surface a sea of fiery plasma, blazing with the intensity of 1,000 suns. Its core, once a furnace of fusion, has burned through its fuel, collapsing under gravity's relentless pull. In this collapse, the star transforms, its energy focused into twin beams of gamma rays that pierce the cosmos like lances of light. These beams are the gamma ray burst, a cosmic scream that travels billions of light years, detectable by telescopes on Earth. Their glow is brief, a matter of seconds or minutes, but their power is unmatched, a spectacle that soothes your mind with its fleeting beauty. Let's drift closer, floating weightless above this radiant giant. The nebula around it shimmers, its colors, blues, purples, and soft reds, blending into a dreamlike haze. You can feel the star's warmth, a distant caress in the cold of space. As the core collapses, the star erupts, its gamma ray beams cutting through the dark, illuminating the nebula with a glow that feels alive. This burst is a cosmic symphony, a pulse of energy that ripples through the universe, calming your heart as you float, carried by the star's final song. The riddle of gamma ray bursts lies in their intensity. Imagine one burst, its light so fierce it drowns out the stars, visible across the vastness of space. Its energy is a torrent, a wave of gamma rays that could outshine a galaxy for a moment. Now picture another, dimmer, its glow a soft flicker, lasting longer than expected. Why such differences? Some bursts last mere seconds, others stretch into minutes, their durations unpredictable. Scientists study these events, tracing their light, their spectra, but the answer remains elusive, a whisper in the cosmic sea, a question that hums, warm and gentle. As you linger, picture the burst beams, twin lances of light that travel forever, carrying the star's final message. These beams are narrow, focused, only visible if they point toward us. This makes gamma ray bursts rare, a cosmic gift that lights the sky for a fleeting moment. The burst energy scatters elements, carbon, oxygen, gold, across the cosmos, seeds that will one day form new stars, new worlds. But what drives the burst power? Is it the star's collapse into a black hole, the spin of its core, or an unseen force? The riddle wraps around you, a lullaby in the starlight, soothing your mind. Picture the star's core, a dense knot of matter collapsing into a black hole or neutron star. As it spins, it channels energy into the gamma ray beams, like a cosmic lighthouse focusing its light. This process is delicate, a balance of gravity, rotation, and magnetism we don't fully understand. Some bursts are tied to black hole formation, others to neutron star mergers. Why do some stars produce these beams while others collapse in silence? Imagine the core's final heartbeat, a pulse that sparks the burst fury. The question hums like the nebula's glow, inviting you to dream without demanding answers. Let's explore the nebula, transformed by the gamma-ray burst touch. The beams have carved paths through the gas, creating glowing arcs that shimmer with ethereal beauty. Dust grains sparkle, reflecting the burst's fading light like tiny mirrors. The burst's shockwave ripples outward, compressing gas, perhaps sparking new stars in its wake. This is the universe's cycle of creation, a dance of birth and death that soothes your soul. But why are some bursts so intense, their energy unmatched, while others are softer? The riddle is a gentle companion, calming your thoughts as you float in the nebula's embrace. Imagine the burst's energy, a torrent of gamma rays that flows through the cosmos, illuminating distant realms. Its light is a bridge, connecting the star's end to the universe's future. Scientists capture this light, piecing together the puzzle of its origins. They find clues in the afterglow, the way the light fades, revealing the burst's environment, its power. But the full picture escapes us, a mystery that lingers in the starlight. Picture the burst beams, glowing faintly in the dark, their energy a cosmic song that soothes your heart. The question is a soft melody, rocking you gently in the cosmic sea. As you drift, picture the burst's legacy, its elements scattered across the cosmos. These are the seeds of creation, the building blocks of planets, of life. The gamma-ray burst is a creator, its energy a gift to the universe. But its mechanics remain elusive. Some main bursts are tied to massive stars, their cores collapsing into black holes. Others come from neutron star collisions, their merger, unleashing a burst of light. Why such variety? Imagine the star's final moment, its core spinning, channeling energy into beams. Is it the star's mass, its magnetic field, or a hidden spark? The riddle hums, a gentle enigma to carry into your dreams. Let's linger in the nebula, exploring its beauty. The burst beams have left a mark, glowing paths that pulse with serene light. The gas swirls, drawn toward the newborn black hole or neutron star, creating a disk that glows like a cosmic jewel. The burst's afterglow fades, but its influence endures, shaping the nebula's heart. Some bursts produce a bright afterglow, others fade quickly. Why the disk difference? Picture the burst's energy, a wave that reshapes the dark. The question is a lullaby, a steady rhythm that calms your mind as you float, weightless in the universe's embrace. Picture the gamma-ray burst's essence, a fleeting flash that carries the star's story to the stars. Its light is a cosmic thread, connecting you to the universe's ancient fires. The burst is a mystery, its power a riddle that wraps around you, warm and gentle. Imagine the beams, piercing the dark, their glow a soft fire that warms your dreams. The enigma of gamma-ray bursts is a whisper, a question that invites wonder without needing answers. You're part of this cosmic dance, a witness to the universe's grandest cry, cradled by the nebula's glow. As you float, feel the nebula's warmth, its light wrapping around you like a blanket. The gamma-ray burst glow is a beacon, its energy a promise of creation. The riddle of gamma-ray bursts is a gift, a gentle question that soothes your soul. Picture the nebula's colors, blending into a dreamlike haze. The burst's light pulses, a steady rhythm that calms your heart. You're a traveler in the starlit dark, witnessing the beauty of a cosmic scream. Let the mystery hold you, like the glow of a distant fire, and drift into the dim night. Imagine the burst journey, its light traveling for eons, reaching distant worlds, perhaps illuminating alien skies. Scientists chase this mystery, studying the afterglow, the spectra, the burst environment. The full picture escapes us, a riddle that lingers in the starlight. Picture the burst beams, a soft fire that warms your dreams. The enigma is a lullaby, a gentle question that cradles you as you drift weightless in the cosmic sea, carried by the universe's eternal embrace. Imagine a star glowing softly in the heart of a nebula, its light a radiant thread woven into the cosmic tapestry. Within its core, it, carries a hidden legacy, not gold or silver, but metals, elements heavier than helium, forged in the furnaces of ancient stars. These metals shape the star's life, its brightness, its fate, binding it to the universe's grand cycle of creation. Yet their presence is a mystery, a gentle enigma that hums in the starlight. How do these metals influence a star's journey? And why do their amounts vary so greatly? The mystery of stellar metallicity is a soothing riddle, inviting us to drift, to wonder, to dream. Picture the star as a celestial jewel, its surface a sea of plasma shimmering with golden light. Its core is a crucible, where hydrogen fuses into helium, releasing the energy that sustains its glow. But woven into this fusion are traces of metals: carbon, oxygen, iron, elements born in the hearts of stars long gone. These metals are the universe's ash, the remnants of supernovae that scattered their essence across the cosmos. They are the star's inheritance, a gift from the ancient forges of creation. But why do some stars carry more metals than others? Their cores enriched or impoverished in ways we can't fully explain? Let's drift closer, floating weightless above this radiant star. The nebula around it glows, its colors, blues, purples, and soft reds blending into a dreamlike haze. You can feel the star's warmth, a distant caress in the cold of space. The metals within it are subtle, invisible to the eye, yet they shape its life. They strengthen its winds, brighten its light, hasten its collapse. A star rich in metals burns differently, its evolution a unique melody in the cosmic symphony. But the mystery of metallicity soothes your mind, a rhythm that cradles you as you float, carried by the star's gentle glow. The enigma of stellar metallicity begins with the universe's history. Imagine the first stars, born in a cosmos of pure hydrogen and helium, free of metals. These giants lived briefly, their supernovae forging the first heavy elements, scattering them into the void. Over billions of years, new stars form from this enriched gas, each generation carrying more metals than the last. Our sun is one such star, its core laced with the ash of ancient explosions. But why do some stars born in the same nebula have wildly different metallicity? Is it the gas they formed from, or a hidden process in their birth? The question hums, warm and gentle, like the nebula's light. As you linger, picture the star's core, a furnace where metals play a quiet role. These elements absorb and scatter light, making the star brighter, its surface more turbulent. A metal-rich star may lose mass faster, its winds carving bubbles in the nebula. A metal-poor star burns more steadily, its life prolonged. But some stars defy expectation, their metallicity too high or too low for their age, or place in the galaxy. Imagine the star's light laced with the ghosts of older stars. Its glow a story of creation. The riddle wraps around you, a lullaby in the starlight, soothing your heart. Picture the nebula, a cradle of gas and dust enriched by ancient supernovae. The metals within it are sparse, yet vital, shaping the stars that form. A nebula rich in metals produces stars that burn hotter, their lives shorter, their deaths more explosive. A metal-poor nebula births stars that glow softly, enduring for eons. But why do some nebulae carry more metals, while others remain pristine? Is it the number of supernovae that enrich them, or a mixing of cosmic currents? The question is a soft companion, calming your thoughts as you float in the nebula's glow. Let's explore the star's life, shaped by its metallicity. A metal-rich star may swell into a red giant sooner, its outer layers spilling into the cosmos. Its supernova will scatter more metals, enriching the next generation of stars. A metal-poor star may collapse quietly, its legacy subtler. These differences are clues, hints at the mystery of how metals influence a star's fate. Scientists study stellar spectra, the light revealing the elements within, but the full picture escapes us. Imagine the star's core, a cosmic alchemist, blending metals into light. The riddle hums like the nebula's haze, inviting you to dream without demanding answers. Imagine the star's formation, a protostar gathering gas from the nebula's heart. The metals in this gas shape its early life, guiding its collapse, its fusion. A metal-rich protostar ignites faster, its light brighter from the start. A metal-poor one forms more slowly, its glow subdued. But some stars form with metallicity that doesn't match their nebula, as if they carry secrets from another time, another place. Picture the protostar's disk, spinning with dust and gas, its metals a hidden spark. The question is a lullaby, rocking you gently in the cosmic sea, a gentle enigma to carry into your dreams. As you drift, picture the star's role in the cosmos. Its metals are a legacy, a bridge between the past and future. When it dies, its supernova will scatter more elements, enriching the nebula for new stars, new worlds. The carbon in your body, the oxygen you breathe, all trace back to stars like this. Their metallicity a gift to the universe. But why do some stars carry so few metals? Their cores, nearly pure, while others are laden with cosmic ash? Is it the galaxy's currents mixing gas unevenly? Or a hidden force? The riddle soothes your soul, a soft melody in the starlight. Let's linger in the nebula, exploring its beauty. The star sits at its center, a radiant jewel in a cosmic crown. Its light pulses, a steady rhythm that calms your mind. The nebula's gas swirls, enriched by ancient metals, glowing with serene light. Some stars in this nebula are metal-rich, others metal-poor. Their difference is a puzzle we can't fully solve. Scientists chase this mystery, studying the light of distant stars, their spectra revealing the elements within. But the answer lies just beyond reach, a shimmer in the nebula's haze, a question that cradles you as you float. Picture the star's essence, its light a story of creation, its metals a record of the universe's past. The metallicity is a cosmic fingerprint, unique to each star, shaping its life in subtle ways. Imagine the star's core, a furnace where metals glow, their presence a quiet force. The enigma of stellar metallicity is a whisper, a riddle that wraps around you, warm and gentle. You're part of this cosmic dance, a witness to the universe's alchemical wonders. The question is a soft fire, warming your dreams as you drift, weightless in the starlit dark. As you float, feel the nebula's warmth, its light wrapping around you like a blanket. The star is a beacon, its metallicity a promise of creation. The mystery of stellar metallicity is a gift, a question that invites wonder without needing answers. Picture the nebula's colors blending into a dreamlike haze. The star's light pulses, a steady rhythm that soothes your heart. You're a traveler in the cosmic sea, witnessing the beauty of a star's hidden legacy. Let the mystery hold you, like the glow of a distant forge, and drift into the night. Imagine the star's legacy, its metals enduring for eons, shaping the cosmos long after its light has faded. Scientists chase this mystery, studying the spectra of stars, the patterns of galaxies. But the full picture escapes us, a riddle that lingers in the starlight. Picture the star's glow, a soft fire that warms your dreams. The enigma is a lullaby, a gentle question that cradles you as you drift, carried by the universe's eternal embrace, a riddle that lingers in the starlight. Picture the star's glow, a soft fire that warms your dreams. The enigma is a lullaby, a gentle question that cradles you as you drift, carried by the universe's eternal embrace. Imagine a nebula, a glowing cradle of gas and dust shimmering softly in the cosmic dark. Within this celestial nursery, a curious entity takes shape, not quite a star nor fully a planet, but something in between. This is a brown dwarf, a cosmic wanderer caught in eternal limbo, glowing faintly in the nebula's embrace. Its existence is a marvel, a testament to the universe's endless variety. Yet, its origins are a mystery, a gentle puzzle that hums in the starlight. Where do brown dwarfs come from, and why do they fail to shine? The puzzle of brown dwarfs is a soothing enigma, inviting us to drift, to wonder, to dream. Picture the brown dwarf as a faint ember, its surface glowing with a soft, reddish light, too dim to rival the stars. It forms like a star, collapsing from a cloud of gas. but it lacks the mass to ignite the fusion that powers true stars. Instead, it hovers in a twilight state, radiating a quiet warmth that barely pierces the dark. Its size is modest, larger than a planet, but smaller than a star, a cosmic orphan, adrift in the galaxy. The nebula around it glows, its colors, blues, purples, and soft reds, blending into a dreamlike haze, cradling this gentle wanderer in its vast embrace. Let's drift closer, floating weightless above this faint glow. You can feel the brown dwarf's warmth, a subtle caress in the cold of space. Its surface is calm, a sea of gas that ripples with faint storms. Unlike stars, it has no fiery core, no fusion to sustain its light. Yet it shines, fueled by the slow release of gravitational energy, a glow that fades over billions of years. This is a brown dwarf's life and quiet existence in the shadows of the cosmos. But why do some clouds form these wanderers while others birth blazing stars? The question soothes your mind, a rhythm that cradles you as you float. The puzzle of brown dwarfs begins in the nebula's heart, where gas and dust collapse to form celestial bodies. Imagine a protostar, gathering mass from the cloud, its core heating as it grows. If it gains enough mass, it ignites, becoming a star. But a brown dwarf falls short, its mass too low to spark fusion. It forms like a star, yet lives like a planet, its fate sealed by its modest beginnings. But why do some protostars stop growing, while others swell into giants? Is it the nebula's density, its turbulence, or a hidden force? The riddle hums, warm and gentle, like the brown dwarf's faint glow. As you linger, picture the brown dwarf's formation, a delicate process in the nebula's cradle. The gas swirls, drawn together by gravity, forming a core that glows softly. A disk of dust and gas spins around it, like a miniature galaxy, but it never gathers enough to ignite. Some brown dwarfs form in isolation, others in clusters, their siblings shining brightly as stars. But their numbers defy prediction, appearing in places we don't expect, hiding in the galaxy's shadows. Imagine the brown dwarf's disk shimmering faintly, its light a whisper of what might have been. The question wraps around you, a lullaby in the starlight. Picture the brown dwarf's life, a solitary journey through the cosmic dark. It drifts, its glow fading over eons, a silent wanderer among the stars. Some brown dwarfs orbit companions, their gravity creating subtle dances in the void. Others roam alone, their paths uncharted. But why are there so many, their numbers greater than our models suggest? Is it the nebula's chemistry, its magnetic fields, or a cosmic quirk? Scientists study these wanderers, tracing their light, their spectra, but the answer remains elusive. A whisper in the cosmic sea, a question that soothes your heart. Let's explore the nebula, shaped by the brown dwarf's quiet presence. The gas swirls in graceful arcs, illuminated by the faint glow of nearby stars. The brown dwarf sits at its edge, a subtle beacon in the haze. Its light is soft, its warmth a gentle pulse that calms your mind. Some brown dwarfs form like planets, condensing from disks around stars, while others form like stars, collapsing from clouds. Why this duality? Picture the nebula's currents, guiding gas into cores that never ignite. The riddle is a gentle companion, calming your thoughts as you float in the nebula's embrace. Imagine the brown dwarf's essence, a faint glow that carries its story through the cosmos. Its light is a bridge, connecting the nebula's past to the galaxy's future. Brown dwarfs are cosmic fossils, their composition revealing the conditions of their birth. Some are rich in metals, others nearly pure hydrogen, their diversity a puzzle we can't fully solve. Picture the brown dwarf's surface, its clouds glowing faintly, its warmth a quiet song. Why do some form with such variety, while others are uniform? The question is a soft melody rocking you gently in the cosmic sea, a gentle enigma to carry into your dreams. As you drift, picture the brown dwarf's role in the cosmos. It may harbor planets, its gravity cradling worlds we can't yet see. Its light, though faint, adds to the galaxy's glow, a subtle thread in the cosmic tapestry. But why do brown dwarfs form in such numbers, hiding in the shadows of stars? Imagine the nebula's heart, where gas fragments into cores, some igniting, others lingering as wanderers. Scientists chase this mystery, studying their infrared glow, their orbits. But the full picture escapes us, a riddle that lingers in the starlight, soothing your soul. Let's linger in the nebula, exploring its beauty. The brown dwarf glows softly, a faint ember in a cosmic crown. The gas swirls, drawn by the gravity of nearby stars, creating waves that shimmer with serene light. The brown dwarf's presence is subtle, its light a whisper compared to the star's brilliance. Some brown dwarfs form in crowded clusters, others in isolation, their origins unpredictable. Why such variety? Picture the nebula's currents, shaping cores that never shine. The question is a lullaby, a steady rhythm that calms your mind as you float, weightless in the universe's embrace. Picture the brown dwarf's legacy, its glow enduring for billions of years, a quiet witness to the galaxy's dance. Its light may guide future explorers, whispering of a cosmic limbo between star and planet. Scientists study these wanderers, their spectra revealing their composition, their history, but the puzzle of their formation remains, a gentle enigma that wraps around you, warm and soft. Imagine the brown dwarf's glow, a faint fire that warms your dreams. The riddle is a gift, a question that invites wonder without needing answers, cradling you as you drift in the cosmic sea. As you float, feel the nebula's warmth, its light wrapping around you like a blanket. The brown dwarf is a beacon, its glow a promise of mystery. The puzzle of brown dwarfs is a whisper, a question that soothes your heart. Picture the nebula's colors, blending into a dreamlike haze. The brown dwarf's light pulses, a steady rhythm that calms your soul. You're part of this cosmic story, a traveler in the starlit dark, witnessing the beauty of a celestial wanderer. Let the mystery hold you like the glow of a distant ember and drift into the night. Imagine a star glowing softly in the heart of a galaxy, its light a radiant thread woven into the cosmic tapestry. Born in a nebula's cradle, it was once part of a shimmering cluster, surrounded by sibling stars, but now it drifts alone, far from its birthplace, a wanderer tracing a solitary path through the galactic wilds. This is stellar migration, the quiet journey of stars across vast distances, reshaping the galaxy's glow. Yet its nature is a mystery, a gentle enigma that hums in the starlight. How do stars travel so far, and what guides their cosmic wanderings? The enigma of stellar migration is a soothing riddle, inviting us to drift, to wonder, to dream. Picture the star as a celestial voyager, its surface a sea of golden plasma, pulsing with a steady light. It moves through the galaxy, carried by the subtle currents of gravity, its path a winding trail across the cosmic sea. The galaxy around it is alive, a swirling spiral of stars, gas, and dust, glowing with ethereal beauty. The star's journey began millions, perhaps billions of years ago, nudged from its cluster by the gentle pull of neighboring stars or the tug of a passing cloud. Now it roams, a lone beacon in the dark. It travels a story written in the starlight. Let's drift closer, floating weightless above this wandering star. The galaxy's glow wraps around you, its colors, blues, purples, and soft silvers, blending into a dreamlike haze. You can feel the star's warmth, a distant caress in the cold of space. Its light is steady, a beacon that cuts through the galactic haze, marking its path across the cosmos. The star's migration is a dance, a slow waltz guided by gravity's unseen hand, carrying it from the galaxy's crowded arms to its quiet outskirts. The mystery of its journey soothes your mind, a rhythm that cradles you as you float. The enigma of stellar migration begins in the galaxy's heart, where stars are born in clusters, their light intertwined like a cosmic family. Imagine a young star glowing in a nebula's embrace, surrounded by siblings. Over time, encounters with other stars or clouds of gas nudge it, sending it on a new path. Some stars drift outward toward the galaxy's edge, while others spiral inward, drawn to its bright core. But why do some stars travel so far, their paths defying our maps, while others remain close to home? The question hums warm and gentle, like the star's distant glow. As you linger, picture the star's journey, a trail of light stretching across the galaxy. It passes through clouds of gas, their wisps glowing faintly in its light. The star's gravity creates subtle ripples, shaping the galaxy's currents. Some stars migrate slowly, their paths steady and predictable. Others move quickly, their trajectories erratic, as if chasing an unseen guide. Imagine the star's encounters, brushes with other stars that alter its course, sending it deeper into the galactic wilds. The riddle wraps around you, a lullaby in the starlight, soothing your heart. Picture the galaxy, a vast spiral of light and shadow, its arms alive with stars. The star's migration is a thread in this cosmic tapestry, a journey that reshapes the galaxy's glow. Some stars travel thousands of light years, crossing entire spiral arms, while others drift only a short distance. Why such variety? Is it the galaxy's structure, its gravitational tides, or the star's own nature? Scientists study these travelers, tracing their orbits, their velocities. But the answer remains elusive, a whisper in the cosmic sea, a question that calms your thoughts as you float. Let's explore the galaxy, shaped by the star's quiet passage. The gas swirls in graceful arcs, illuminated by the light of countless stars. The wandering star moves through this cosmic sea, its glow a subtle beacon in the haze. Its migration is influenced by the galaxy's heartbeat, the gravitational pull of its core, its arms, its dark matter halo. Some stars are flung outward by close encounters, others drawn inward by the galaxy's embrace. But why do some paths defy prediction? Their journeys too fast, too strange. The riddle is a gentle companion, soothing your soul as you drift in the galaxy's glow. Imagine the star's encounters, moments that shape its path. A nearby star passes, its gravity nudging the wanderer, altering its course. A cloud of gas brushes past, slowing its journey, adding dust to its faint glow. These interactions are the galaxy's dance, a full choreography of light and gravity that guides the star's migration. But some stars travel alone, their paths untouched by others, as if following a cosmic map we can't see. Picture the star's light, a trail that stretches across the galaxy, its journey a story of freedom. The question hums like the galaxy's haze, inviting you to dream without demanding answers. As you drift, picture the star's role in the cosmos. Its migration carries it through regions of starbirth, where its gravity may spark new protostars. It passes through quiet voids, its light a solitary glow in the dark. The star is a traveler, its journey a thread in the galaxy's story. But why do some stars roam so far, while others stay near their clusters? Is it the galaxy's tides, the pull of dark matter, or a hidden force? Scientists chase this mystery, studying the motions of stars, their paths across the sky. But the full picture escapes us, a riddle that soothes your heart. Let's linger in the galaxy, exploring its beauty. The star moves through a spiral arm, its light blending with the glow of countless others. The gas swirls, forming clouds that shimmer with serene light. The star's migration is a quiet force, its gravity shaping the galaxy's currents. Some stars migrate in groups, their paths aligned, while others wander alone. Their journeys unpredictable. Why such diversity? Picture the galaxy's heartbeat, its gravity guiding the star's path. The question is a lullaby, a steady rhythm that calms your mind as you float, weightless, in the cosmic sea. Picture the star's essence, its light a story of travel, its migration a record of the galaxy's dance. The star is a wanderer, its path, a cosmic poem written in the dark. The enigma of stellar migration is a whisper, a riddle that wraps around you, warm and gentle. Imagine the star's glow, a faint fire that warms your dreams. You're part of this cosmic journey, a witness to the universe's wandering lights. The question is a soft melody, rocking you gently in the galaxy's embrace, a gentle enigma to carry into your dreams. As you float, feel the galaxy's warmth, its light wrapping around you like a blanket. The star is a beacon, its migration a promise of adventure. The enigma of stellar migration is a gift, a question that invites wonder without needing answers. Picture the galaxy's colors blending into a dreamlike haze. The star's light pulses, a steady rhythm that soothes your soul. You're a traveler in the starlit dark, witnessing the beauty of a cosmic wanderer. Let the mystery hold you, like the glow of a distant trail, and drift into the night. Imagine the star's legacy, its journey enduring for eons, shaping the galaxy long after its light has faded. Scientists chase this mystery, studying the orbits of stars, the structure of galaxies. But the full picture escapes us, a riddle that lingers in the starlight. Picture the star's glow, a soft fire that warms your dreams. The enigma is a lullaby, a gentle question that cradles you as you drift, carried by the universe's eternal embrace. Imagine a universe in its infancy, a vast and formless void, cloaked in darkness after the Big Bang's fiery birth. In this primordial sea, no stars yet shine, no galaxies spin. But then, a spark ignites, a faint glow, the first star, a cosmic pioneer piercing the eternal night. These are the first stars known as Population 3, born in a cosmos of pure hydrogen and helium. Their light the universe's opening, verse, yet their nature is a mystery, a gentle riddle that hums in the starlight. What were these stars like, and how did they shape the cosmos? The riddle of the first stars is a soothing enigma, inviting us to drift, to wonder, to dream. Picture the early universe as a sea of gas, swirling softly in the dark, illuminated only by the faint afterglow of creation. The gas is pristine, untouched by the metals that later stars would forge. Gravity begins its work, pulling hydrogen and helium into dense clouds, the first stellar nurseries. Within these clouds, the first stars take shape, collapsing under their own weight, their cores heating until they ignite. These stars are massive, far larger than our sun, their light a blazing white that cuts through the cosmic haze. Their glow is a primal song, a melody that soothes your heart as you float in the universe's dawn. Let's drift closer, floating weightless above this ancient cosmos. The gas clouds shimmer, their colors, silvers, grays, and faint blues, blending into a dreamlike haze. You can feel the first star's warmth, a distant caress in the cold of space. Its surface is a sea of plasma, roiling with energy. Its core a furnace where hydrogen fuses into helium, releasing a torrent of light. These stars are giants, their lives brief but brilliant, burning for mere millions of years before collapsing in spectacular supernovae. The mystery of their nature calms your mind, a rhythm that cradles you as you drift in the starlight. The riddle of the first stars lies in their elusiveness. Imagine these giants, born in a universe we can only glimpse through theory and simulation. They were massive, perhaps hundreds of times our sun's mass, their cores pure and untainted by metals. Their supernovae forged the first heavy elements, carbon, oxygen, iron, scattering them into the void, seeding the gas that would form galaxies, planets, and life. But why were they so massive? And how did they form in such pristine conditions? Scientists chase this mystery, searching for their echoes in the cosmos. But the answer remains a whisper in the cosmic sea. As you linger, picture the first star's life, a fleeting blaze in the dark. Its light illuminates the surrounding gas, ionizing it, creating glowing bubbles that shimmer with ethereal beauty. These stars were the universe's architects, their explosions shaping the cosmos, triggering the formation of galaxies. But their details are uncertain. Were they all massive, or did smaller stars exist among them? Imagine the star's core, a crucible where the universe's first light was born. Its energy, a primal force. The riddle wraps around you, a lullaby in the starlight, soothing your soul as you float in the cosmic dawn. Picture the first star's supernova, a cataclysm that lights the universe for a fleeting moment. Its shockwave ripples through the gas, compressing it, sparking new stars in its wake. The elements it forges, metals that didn't exist before, blend into the cosmic sea, enriching it for future generations. These supernovae were the universe's first alchemists, transforming simplicity into complexity. But why did some first stars explode so violently, while others may have collapsed silently into black holes? The question hums, warm and gentle, like the star's fading glow, inviting you to dream without demanding answers. Let's explore the early universe shaped by the first star's light. The gas clouds swirl, illuminated by their primal glow, forming the seeds of galaxies. The stars' supernovae create turbulence, their shock waves weaving a cosmic web of filaments and voids. These stars were pioneers, their light the universe's first chapter, but their formation is a puzzle. How did pristine gas collapse into such massive cores, and why were they so different from today's stars? Picture the gas clouds, dense and turbulent. Their collapse, a delicate dance of gravity and heat. The riddle is a gentle companion, calming your thoughts as you float in the cosmic haze. Imagine the first star's core, a furnace where fusion begins, its light piercing the dark for the first time. These stars were pure, their cores free of metals, their fusion unhindered by the complexity of later stars. But some theories suggest they formed in pairs, their orbits shaping their lives, while others stood alone. Why such variety? Scientists study the echoes of these stars, their metals, preserved in ancient metal-poor stars we can observe today. But the full picture escapes us, a mystery that lingers in the starlight, soothing your heart as you drift in the universe's embrace. As you drift, picture the first star's legacy, their elements woven into the cosmos, forming the building blocks of galaxies, planets, and life. The carbon in your body, the oxygen you breathe, all trace back to these pioneers, their supernovae, a gift to the universe. But why were they so massive? Their lives so brief? Imagine the early universe, a sea of gas lit by their primal glow, its structure shaped by their explosive ends. The riddle hums like the cosmic haze, a gentle melody that invites wonder without needing answers, cradling you in the starlit dark. Let's linger in the early universe, exploring its beauty. The first star glows, a solitary beacon in a cosmic crown. The gas clouds swirl, forming new stars, their light blending into a primal symphony. The first star's supernovae have left a mark, glowing remnants that shimmer with serene light. Some form black holes, their gravity shaping the cosmos, while others scattered metals in explosive bursts. Why such diversity? Picture the star's supernova, a wave of light that reshapes the dark. The question is a lullaby, a steady rhythm that calms your mind as you float, weightless in the universe's dawn. Picture the first star's essence, its light a story of creation, its supernova a cosmic poem written in the dark. The riddle of the first stars is a whisper, a gentle enigma that wraps around you, warm and soft. Imagine the star's glow, a primal fire that warms your dreams. You're part of this cosmic tale, a witness to the universe's first light. The question is a soft fire soothing your soul as you drift, carried by the universe's eternal embrace. The first stars are gone, but their echoes linger, a melody that cradles you in the cosmic sea. As you float, feel the early universe's warmth, its light wrapping around you like a blanket. The The first star is a beacon, its glow a promise of creation. The riddle of the first stars is a gift, a question that invites wonder without needing answers. Picture the cosmic haze, its colors blending into a dreamlike glow. The star's light pulses, a steady rhythm that soothes your heart. You're a traveler in the starlit dawn, witnessing the beauty of the universe's first sparks. Let the mystery hold you, like the glow of a distant fire, and drift into the night. Picture yourself floating in the heart of the cosmos, a weightless traveler cradled by the universe's gentle embrace. The stars surround you, their light a soft glow that weaves a tapestry of dreams. You've journeyed through the mysteries of star formation, evolution, and collapse, drifting through nebulae, witnessing the birth of massive stars, the dance of binaries, the winds that sculpt the void. You've pondered supernovae, neutron stars, black holes, and gamma ray bursts, each a riddle wrapped in starlight. The metals within stars, the wanderings of brown dwarfs, the migrations across galaxies, and the primal glow of the first stars have all sung their lullabies, guiding you deeper into the cosmic sea. Now, as you linger in this starlit haven, the galaxy's glow wraps around you like a blanket, warm and eternal. The nebulae shimmer, their colors, blues, purples, and soft silvers, blending into a haze that soothes your soul. Each star is a story, a spark of creation that hums with the universe's heartbeat. You floated through their cycles, from the gentle collapse of gas clouds to the fiery end of supernovae, each moment a whisper of wonder. The mysteries remain unanswered, yet comforting, like a melody that lingers in the dark, inviting you to dream without needing solutions. Feel the cosmos holding you, its light a steady pulse that calms your heart. The stars are eternal, their journeys spanning billions of years, yet here, in this moment, they are yours, a constellation of peace. Imagine the first stars, their primal light piercing the dawn of time, their supernovae scattering the seeds of life. Picture the black holes, silent voids that bend the fabric of space, and the brown dwarfs, faint wanderers caught in cosmic limbo. Each is a thread in the universe's grand tapestry, and you are woven into it, a silent witness to creation's endless dance. As you drift, let the galaxy's glow carry you deeper, its warmth a promise of rest. The riddles of the cosmos, star formation, stellar, winds, migrations, are lullabies, their questions soft and unhurried. You don't need to solve them tonight. The universe is vast, its secrets patient, waiting for you in dreams. Picture a nebula, its gas swirling gently, illuminated by the light of newborn stars. Its colors fade into a dreamlike haze, a cradle that rocks you softly in the starlit dark. The cosmos is your home, its glow a beacon that guides you to sleep. Imagine the stars pulsing, their light a rhythm that soothes your mind. You're weightless, floating in the cosmic sea, carried by the universe's eternal embrace. The mysteries you've explored are gifts, whispers of wonder that linger in your heart. Let them hold you in them, like the glow of a distant star, their stories blending into a dreamlike melody. The galaxy hums, its light a lullaby, and you are part of its song, a traveler in the starlight. Drift now deeper into the night, where the cosmos cradles you, and let the stars guide you to sleep.